All right, welcome back, Hononegah, Algebra 1. We're starting Chapter 5. New chapter for some of you, fresh start here. A little bit of exploration, and obviously sometimes we would have this be more of a partner activity, but find the point where the two lines intersect. So I'm looking at this picture, and I'm seeing where the two lines are actually going to cross at. And so these two cross at the point 0, -2. Now, what I want to do is I want to verify right now, and this is not something we're normally going to do is verify, but you can check your answers, meaning if I put 0 in for x and -2 in for y, does it actually work in the top equation? So 5 times 0 would be 0, -4 times -2 would be 8. So does 8 equal 8? Yes, it does work in the top equation. And then I want you to try it for the bottom equation. So -0, 2 times -2. And so -0 is still 0. 2 times -2 is -4, and it also equals -4. So that's how to verify that it actually works in both equations. So the next one, we have -3, -1, and I want to verify, there's the point they cross at, I want to verify that it works. So 4 times -3 minus 6 times -1, does it actually equal -6? So -12 plus 6, and it does. -6 does equal -6. So that's the top equation here. Next one, 4 times -3 minus 4 times -1, does that equal -8? So -12 plus 4, and it does. So that's just to verify. When you graph two equations, the point of intersection is actually the solution, for both equations. Now, each line has many other points that it can have, but that is the only point that actually works for both equations at the same time. So what we're going to talk about today is solving a systems of equation by graphing. The solution of a system for two variables is the point of intersection, or the ordered pair for the solution for each equation. So all they want to know is whether or not yes or no, it works or it doesn't work. So if I plug 2 in for x and 5 in for y, 5 in for y, does it work in the top equation? The answer to that so far is yes. If I put 2 in for x and 5 in for y, does it work in the bottom equation? So 2 times 2, 3 times 5. And again, it does work in the bottom equation. And so therefore, if it's yes for the first equation and yes for the second equation, then it's yes for the entire question. If either one is a no, it's a no for the entire question. So just because it might work in one equation, it may not work in the other. For instance, in this one, 0 in for y, -2 in for x, it does work in the top equation. -2 for x and 0 for y, but it doesn't work in the bottom. So therefore, the answer to this is no, because it does not work in the bottom equation. And you don't need to explain here's what you need to do. You need to show your work. Like, you need to show why you said no. You can't just say nope or yes. You ultimately need to show why you said that. So again, plug in for x, plug in for y. If it works, then it's a yes. So solving by graphing. Now we're going to take our graphing skills that we did previously, slope and y-intercept back in chapter 3, okay, graphing a line, and then we're going to find the point of intersection. So the top equation has a slope of -2 and a y-intercept at 5. So I'm going to go over to the graph. I'm going to go up to 5, and I'm going to put a dot, and I'm going to go down to over 1. So I'm going to graph the line, and I'm going to try to be as neat as I can, because ultimately I have a second line that I need to graph, and I'm going to do this one in a different color here. Slope of 4, y-intercept at 0, -1. So -1 with a slope of 4. And they cross at the point 1, 3. So that is my answer. The point of intersection between the two lines is the solution. Now, the next one, I got to do a little bit of work here. I need to subtract 2x so that I can find my slope and my y-intercept. So it needs to be a y equals equation in order to find your slope and your y-intercept. So I graphed the top line. Second one, I'm going to solve for y. So I'm going to subtract 3x. This one gets a little bit more complicated now, dividing everything by a -2. So positive 3/2 x minus 2. So the slope is 3/2 and the y-intercept is 0, -2. 0, -2, up 3 to the right 2, up 3 to the right 2. They cross. The point of intersection is the answer. So solving a system by graphing. You try. So hit pause and see if you can do these two both by yourself. All right, welcome back. So the top one has a y-intercept at 0, 3 with a slope of positive 1/2, so up 1 over 2. Notice that I am graphing a lot of points here because ultimately, A, I want my line to be straight, but B, when they do intersect, I want to know exactly what point they intersect at. So the next one, again, those of you that like a little bit of color, you probably do that. You got 0, -5 with a slope of -3/2. I know I didn't write it down for the top one, but there it is. Whoops, that's a positive 3. So now 0, -5. Slope of -3 to the right 2. Now it's going away from my other line, so I'm going to go positive 3 with a -2. So up 3 to the left 2. And I see that they are going to cross now. And the point of intersection is the answer. So 1, 2, 3, 4. So -4, positive 1 is the point that those two lines will cross at. So this is section 5.1 here. Real world problems can be a little bit challenging, and they don't even give me the equation, which also makes this a little bit more challenging. So 30 bundles of shingles plus 4 rolls of roofing paper, and that's going to cost me $10.40. And then the other one says 8 bundles of shingles is $2.56. Well, this they're giving me. They're telling me that 8 bundles of shingles is $2.56. So if I go ahead and divide by 8, x equals 32. So if I was going to graph this an x equals line, it'd be a straight up and down line at 32. Now the other one is a little more challenging to graph. And again, you can actually find this example in your book, but I'm going to solve this top one for y. So I'm going to subtract 30x. And I'm going to give myself some space here. 4y is equal to -30x plus 1040. And then I'm going to divide everything through by 4. So y is equal to -15/2 or 7.5x plus 260. Now that's a little more complicated to graph, which is why I laughed when we did this question here, is because my slope and my y-intercept are a little more challenging. But 260, okay, for a y-intercept would be right in the middle here at 260. Now, what I like to do sometimes when I have this type of situation is I like to just find the x-intercept and the y-intercept. And so when I find the x-intercept here, basically I'm doing 1040. If I do the cover-up method and divide by 1040, I end up going here. And so the intersection is the hard part here. Like, where do they actually cross? And I know the x-coordinate is at 32. So if I plug 32 actually in for x and solve this, 32 times 30 is 960 plus 4y equals 1040. And 4y would equal 80. And y would equal 20. So the point 3220 is the intersection. And again, that's hard to see on the graph. But what does that mean? That means the shingles cost $32 each for shingles. And the roofing paper costs $20 each. We are going to do much, much, much more word problems later when we get into elimination and substitution. So this question, doing it by graphing, is a little bit more challenging, is to actually come up with the intersection. So last example here, or I apologize. Your homework assignment then, okay, is to test these points to decide whether or not they work in both equations, or to work on solving by graphing, looking at the actual graph. So if you have any questions, make sure you talk to your teacher, and good luck.